Hi, today I'm going to discuss Semester 3 Mathematics for Computing 2 2016 Paper 1 question number 11 to 15. Question number 11. Here we have to consider the limit of this when n goes to infinity. That means when limit n goes to infinity of xn, that is equals to limit n goes to infinity 1 plus n over 1 minus n. Before any simplification, first just imagine what will happen when we replace all the n terms by infinity. In that case, for the numerator, n plus 1. That means infinity plus 1. Again infinity. For the denominator, 1 minus infinity, you will have the negative infinity. That is not defined. So in that case, you have to simplify this term by using basics of algebra, and then you can check whether what is happening there by replacing remaining n terms by infinity. So I'm going to take n as a factor for both numerator and the denominator. Then first term will be 1 over n plus 1. For the denominator, we will have 1 over n minus 1. See, when we remove the brackets, you will have the same thing. So we can use the equality. So we can cancel n terms for the numerator and the denominator. Then again check what will happen when we replace all the n terms by infinity. So I can insert limit n goes to infinity for each term separately. In that case, for the numerator we have limit n goes to infinity 1 over n plus limit n goes to infinity of 1. Limit n goes to infinity of a constant is equals to 1. So we have 1 again. For the denominator, same as before, we have limit n goes to infinity 1 over n and minus 1 since we have a constant term there. But when we consider these two terms, both will be goes to 0. Because just imagine what will happen when we take limit n goes to infinity 1 over n. In that case, when we replace n terms by infinity, we will have 1 over infinity, that is equals to 0, obvious. So we can replace the values. Since we do not have any not defined term, we have 0 plus 1 for the numerator, for the denominator 0 minus 1. When you simplify this, we have minus 1. Minus 1 is there in D. So the answer is D only. Since it is a constant, definitely out of these 5 you will have an unique answer. Question number 12. A quadrilateral ABCD is a parallelogram if. So let's focus on a parallelogram with the vertices ABCD. Suppose we have something like this with the vertices ABCD. To be a parallelogram, opposite sides should be parallel and equal. So AB parallel and equal to BC. Similarly, BC is parallel and equals to AD. We can represent these two relations by using vectors. AB vector equals to DC vector. That implies AB is equals to DC in magnitude. AB line is parallel to DC and same direction. That's why I used from A to B, from D to C. Direction same. For the other pair we have when we consider AD side and BC side, AD vector is equals to BC vector. In that also we have three properties. That means AD is equals to BC in magnitude, AD is parallel to BC line and same direction. As I told you before, that's why I selected from A to D as the direction and B to C as the direction. So out of these two we have the first one, AB equals DC. So C is correct. What about the others? First one, AB equals CD. Magnitude same, but direction can be different. So those two will not be parallel. So this is not the case to imply ABCD is a parallel. What about B? AB vector equals to BC vector. AB vector and BC vector. AB this and BC this. When those two vectors are equal, ABC will be a straight line because direction should be same. So A, B, C. If those two vectors are same, equal, then magnitude of these two line segments will be same and direction should be same. Right? Since we are considering a common point there, ABC will be a straight line. Then what about E? AD equals to 2BC. AD equals to 2BC. That means you will have something like this. For example, you will have several combinations for this property. I am considering this case. AD vector equals to BC times 2. So AD will be somewhere here. BC into 2 times. Then here we have D. Right? So it is obvious the opposite sides are not equal in length. So E is not the case. What about D? AB vector is equals to BD vector. AB vector and BD vector. AB a side, BD a diagonal. But the case is opposite side should be equals. The vectors which are along the opposite sides should be equal. So D is also not the case. So the answer is only C. Only C. Question number 30. Here we have to focus on a rhombus OABC. OABC, 4 vertices. If it is a rhombus, definitely all the 4 sides should be equal in length and opposite sides will be parallel. So we have 3 identities. First one, OA equals, AB equals, BC equals CO in length. And when we consider the opposite sides OA and CB, in vectors we can write it as OA vector is equals to CB vector, since those two are same in length, parallel, same direction. When we consider the remaining pair, we have OC vector is same as AB vector. In that case also we are considering three properties. OC is equals to AB in length and the direction will be same, and OC parallel to AB. So what about A? AB equals OC. AB is this side equals to OC. That is correct. B. OA plus OA vector plus AB vector equals OB vector. So when we focus on OAB triangle, we can apply vector addition by using this triangle. In that case, when we consider the starting point as O, end point as B, the direction of the vector will be from O to B, and we can complete this journey by starting from here, and we have to end up at the point B, and we have to consider this triangle. So we have considered the same sequence in an order, so we can add these two together. Since this is the common point, the summation will be OB equal. So B is also correct. C. AC equals AB vector plus CB vector. AB vector. AB vector from here to here, the direction, plus CB vector plus CB vector from here to here. So this is the starting point when we consider AB plus CB. From the starting point to the end point, we will have AC. To have AC, we have to start from here, end up at C, then journey will be go from here to here, then here to here. So the direction should be B to C, not C to B, to have AC. This is the starting point, this is the end point. So you will have AC when we go through AB plus BC, not this, plus BC. So C is incorrect. D. When we consider D, what we have is OA vector plus AB vector equals OC vector plus CA vector plus AB. By considering the vector addition law I have discussed in B and C, we can apply the same addition rules for this equation. In that equation, we have to get the summation of these two. Then we have the common point as A, not an issue. We have considered the vectors, two vectors in the same order. So the addition will be from O to B. For the right hand side, this is the left hand side. For the right hand side we have, when we simplify that, we can add these two together since we have the common point as C. So summation of OC and CA will be given when we consider OCA triangle. That is equals to from O to A, starting point to the end point. Then we have to add AB again. Then again we have OA and AB vectors in an order. So we can get the summation since this is the common point. Summation becomes OB. So finally we have left hand side is same as the right hand side. So D is also true. E. AC equals BC. When we consider AC and BC, AC from A to C and BC from here to here, a diagonal and a side, it is obvious two vectors are not equal. So E is incorrect. So the answer is A, B and D only. Question number 14. Here we have three vectors x, y and z, where a, b, c components are positive integers. So a, b, c belongs to z plus, and they have given that x is perpendicular to z minus y. So basically if you have two vectors a and b, if those two are perpendicular, we know that a dot b is equal to 0. Not 0 vector, it is 0. Because dot product gives a scalar. Then we can simplify this by finding z minus y. Z minus y is equals to the difference between the components of z and y. So we have for I, we have a component for j, and we have a component for k as well. Always the component will be given when you get the subtraction between z component and y component according to the given order. Z minus y. Then we have a minus 1, and for j we have 1 minus b. For k we have c minus c, that is 0. So this term will be goes to 0. So finally we have a minus 1i, 1 minus bj only. Since x is perpendicular to this vector z minus y, we can take the dot product between x and z minus y, that is equals to 0. Dot product means when we have vectors in component form, the summation of the multiplication of the corresponding components is equals to 0. So the multiplication between I component of x with the multiplication of the I component of z minus y. So we have a minus 1 into the component of I, that is a in x, plus z minus y, that is 1 minus b. The j component of x is b again. Since we have 0 here, the multiplication with 1, that is 0. So right hand side will be 0 again. When you simplify this, we have a squared minus a plus b minus b squared equals 0. Then we can consider a squared minus b squared together, and I'm going to consider minus 1 as a factor of minus a plus b. Then we have a minus b here, and a equals to 0. So by the method of completing squares, the difference of complete squares, we have a minus b into a plus b here, and here we have a minus b again equals to 0. Here we have two terms. For both we have a minus b as a factor. Then we have a plus b minus 1 equals 0. So here we have a minus b equals 0 or a plus b minus 1 equals 0. That means a plus b equals 1. Since we consider only the positive integers for a, b, c unknowns, a plus b can't be equals to 1 since those are positive integers. There are no positive integers when the summation becomes 1. So this is incorrect. We have only this under the given conditions. That is there, only E. So the answer is only E. Question number 15. Here we have to focus on the bounded area by the four curves given. First one, x equals 0, that is the y-axis. Second one, y equals 0, that is the x-axis. Third one, x equals 1, somewhere here, x equals 1. Fourth one, y equals 3 plus e minus x, that is derived by e to the power minus x, that is passes to 0, 1 point. Similarly, e to the power x will be something like this. So you can add 3 for that. You will have e to the power 3, e to the power minus x plus 3 somewhere here. Then we have a curve like this. Then the bounded area will be this. So capital A, 0 is here, 1 is here. You can find that by integrating this y equals 3 plus e minus x from 0 to 1, because area under the curve is given for capital A. So capital A is given when you integrate from 0 to 1 the function 3 plus e minus x dx. That is the required area. So you can simplify that. When you integrate 3 by x, we have 3x plus is there. We have to integrate again e to the power minus x. You know that integration of e to the power kx into the variable with respect to the variable x, we have e to the power kx over k. So since we have e to the power minus x here, the constant k is minus 1. So we have e to the power minus x as it is divided by the constant minus 1. We have to find the definite integral from 0 to 1. Then you can simplify this. Here we have 3x minus e minus x from 0 to 1. Then we have the same function evaluated when x equals 1 minus the same function when we evaluate when x equals 0. When x equals 1, 3x minus e minus x, x equals 1, we have 3 minus e minus 1. When x equals 0, we have 0 here minus the second term e to the power minus 0, that is e to the power 0 is 1. Then you can simplify. We have 3 minus e minus 1 is 1 over e minus minus plus 1. Then we have 4 minus 1 over e as the answer. That is there in C. So the answer is only C. Thank you for joining. See my next video for question number 16 to 25.